right. You guys hungry for knowledge, I hope? Lunch is coming. 6 years of Gradle at LinkedIn. In 2011, I got a call from my boss, Hans Doctor. He's the CEO of Gradle, and he's the founder of Gradle. And he tells me, hey, Szczepan, you wrote something about LinkedIn on your blog. Can you change that, please? And I was good scared. LinkedIn was one of the critical clients for Gradle at the time. And I was the consultant for LinkedIn. And I look at my blog, and there it is. On my About page, it says LinkedIn is quite useless. It's not a great idea. Like, be nice on your blog, because you might, in some time in the future, be consulting for the teams that develop those software products, or even be a part of that team. So that's actually what worked for me. It's funny that the director that called my boss at the time, he's kind of now my boss. So it's interesting. And thank you very much for coming. I will talk about various ambitions that LinkedIn had with Gradle. And we've built automation and how we have fulfilled those ambitions. Back in 2011, LinkedIn was really critical client because of those ambitions, because of the use cases that were driving various important features in Gradle and how we can solve them. I'm Szczepan Faber. I come from Poland. My name is awesome for living in the US. I've never had to spell it ever yet. By the way, how many of you use Mockito? Okay. How many of you don't use Mockito because you use something else? Cool. Oh, okay, cool. Cool. You should go to my other talk in 2 hours about Mockito V2. Maybe I can change your mind. My team at LinkedIn deals with development tools. Example tools that we provide to our engineers is LinkedIn-specific IntelliJ plugins so that IntelliJ understands the developer workflow at LinkedIn and makes engineers at LinkedIn more productive. Also, we do code review tools, continuous integrations, many more, and Gradle as well. My team is around 30, total tools team at LinkedIn. Tools for engineers is a big thing at LinkedIn. It's around 300, and total engineering around 3,000. And my team is hiring, so you can work in my team. It's pretty awesome. You can work with me, and I work with myself all the time, and it's a pretty good experience. It's pretty cool. And we started with Gradle at LinkedIn in around 2011. And one of the use cases that were driving the adoption of Gradle and trying out Gradle was how we were doing software at LinkedIn at the time. So the code base was pretty much monolithic. So all software components, everything in single giant repo. And the development was slow. It wasn't scaling very well. We had problems with releases. Releases were not frequent enough. They were stressful. Rolling back things was hard. Testing things was hard. How many of you is on monorepo now? Uses monorepo architecture? Oh, not many. Okay, some of you. Okay, cool. And what happened is we did this project called Inversion, which attempted to address that situation and introduce some quality and consistency in the development so that we can have fast releases, fast iterations, and essentially be productive. And Gradle was brought into LinkedIn around that time. We were looking for some ways to address certain use cases that we had. We used Ant to build that monorepo. Anybody uses Ant? Should move on. Don't use. I give a hug later on if you use still Ant. And we chose Gradle because it was flexible. It had its nice Gradle plugins API. Also, we liked the parallel building that was coming. Also, the incrementalness and build avoidance, avoiding doing unnecessary things during the build was critical for us because we wanted to have fast experience for engineers. And incremental builds in Gradle is really cross-cutting. It's really part of the platform. Everybody can take advantage of that. However, the most important feature that we were looking at was various APIs and promised that Gradle will be really good with dependency management. That was important for us because we had this monorepo, and we were thinking that we need to have separate code bases, individual versioning of software components, and that brings us to the world of dependency management, versioning, conflicts, and all that joyful things. And we saw Gradle as something that can help us. And at the time, Gradle was even pre-1.0, which was troublesome. It was hard to sell Gradle outside of LinkedIn, inside LinkedIn. This is pre-1.0. And there's something magical about 1.0 version. If you have a software project, go for 1.0 early. Trust me, you're going to get more adoption. You don't have to wait until your tool is perfect. this is what we have done within the Gradle team. I was a part of the Gradle core team at the time when I was working. When I started, there were like 4 of us, so Gradle was really tiny, like 2 engineers, including myself. And we had those self-imposed constraints that, Gradle has to ship with the Gradle daemon, super stable, working on Windows, on everything, and turn on by default. And guess what? Like the daemon was turned on by default in Gradle just last year. So it took like many, many years. And those constraints that we had and we were thinking that you release 1.0 once in your lifetime, it gotta be perfect. I don't think it was good. And my guidance is like prefer momentum over perfection. And one of my favorite authors, Peter Bregman, I got a couple of quotes from him. I really, like the way he talks about perfectionism really resonates with me. And I value way more like small, incremental, imperfect steps and that give you this glimpse of perfection sometimes. Like have the perfection in your vision, but that don't slow down. So that was 1.0, and finally we had 1.0. Let's get back to mono versus multi-repo. So I talked that in the early times, before the project Inversion, we had mono repo at LinkedIn. So what do you think? What is the current strategy or architecture at LinkedIn when it comes to repositories? Multi? It's actually none of them. Like we don't have mono nor multi, or maybe we have both. Kind of depends how you see it. The way we do it is like we made it so that the mono versus multi is an implementation detail. And I want to zoom into that a little bit. One of the issues with the mono repo that we had, and I'll tell also some of the good things about mono repo, so like bear with me, is that like all the software components in that like giant blob of code are like built at the same time, which means that if I have to revert one single change in one of the component, I have to like revert everything. I sort of build and version that whole thing together. And that was not really working for us. It was hard to like test things in isolation, deploy in isolation. So we saw that let's try to do something different, go to separate code bases and do some individual versioning. What we've done is we introduced a concept of a multi-product at LinkedIn, and multi-product at LinkedIn is a bad name, by the way. I don't like this name. It's like a code base. Consider it a code base. And it makes the mono versus multi sort of an implementation detail because some of the multi-products are very simple and they are built on top of a single Git repo. However, some other multi-products have code base that resides in multiple repositories and sometimes even like different repositories, different SCM systems, like most of the code in Git, but some of the code in Subversion, or most of the code in LinkedIn proprietary Git repo, and some of the code open sourced at GitHub. So like this is all possible because we have that layer of abstraction on top of the multi, mono, and repositories. And we believe in separate code bases, but not necessarily separate repositories. That's an implementation detail. We even have multi-products that are that basically the code base of that multi-product is part of some like big repo, part of some big mono repo. So that's also possible, like in our case. But then if we have separate code bases and we start to build the code separately, we have the problem with versioning and with conflicts. And I'm getting to how Gradle will help us. And in this like very simple dependency graph, we have 3 software components with some dependencies. And when those software components are part of one code base, like there's just no problem. They just use some classes or some from some component. So that's easy. Now it's getting interesting when we do individual versioning. When the B, A, B, and C are part of separate code bases and they're built and versioned separately, what's happening is that I can have multiple versions of B, 1 and 2, and that's okay. I can have even many, many versions, which is not good. But generally, like things like that happen. And what's next is, like, what if we spice up this dependency graph and we have component D that suddenly picks up A and C, and it's getting this version conflict, right? Like transitively, we are picking up different versions of B, and that can break the world. So that's that problem that we're facing. So let me get into the details, and then Gradle, I promise you. So some pros of this individual versioning of software components and kind of going to separate code bases is that we can have incremental gradual rollouts. This means that if I have a change, I can slowly roll it out and have some risk mitigation strategy. Or I might even not have somebody pick up the newer version because he does not need it. Also, it's also important for certain kinds of changes that we do. I'm a big fan of compatibility. Just the world of software would be so much nicer if things were compatible. Just so much easier. I don't like this kind of radical approach that frequent deprecation, kind of frequent removal of deprecated code. It's I understand that from time to time you gotta remove some APIs that are blocking you or impediment to your development. But in general, being compatible is nicer, better. It helps everybody. And sometimes you do those incompatible changes purposefully, and you know that you gotta break the API. You should do the major version release at the time, so we do that. But if we have separate code bases, separate versioning, I don't have to roll out that incompatible change to everybody at the same time. I can do it gradually. Or even I can say, hey, there are some legacy applications out there, low importance to the organization. They will not pick up this newer version ever. They're going to stay on old version, that's OK. If I have a single code base, I kind of have to consider all the usages, right? If I'm changing the behavior, I have to update all the clients. And if I have a million clients and giant repo, it's kind of making it harder. Another pro I see is the fact that I can have some independent dependencies. And I'm going to give you a specific example. If I have a big repository, and let's say I use JUnit for testing, I probably have one version of JUnit for all my tests. And if I need to bump the version of that JUnit, I have to update all the tests. And if my monorepo is giant, I have to update 1 million tests. If I have separate code bases, one multi-product can use JUnit 4, another JUnit 5, another testng, and even I might have some legacy code that uses still JUnit 3, but it's fine. Things work. I don't have to do this heroic effort in upgrading everybody if I want to bump the dependencies. So separating code bases and independent dependencies is useful at times. So those are the things. Independent versioning also comes with some cons. And those are big problems. Version conflicts, when you have complex dependency graph, and you have some transitive issue that hits you in production at runtime that was, for some reason, not caught during testing. And you investigate, and it's 10 level deep into the dependency graph. That's kind of hard. You have multiple versions in use, sometimes stale versions in use. Because this version works for me. I don't need to update ever. And then at some point, oh, there's a bug fix that we need to have. But now we have 3 years of versions that we need to update, and nothing works. And we are in alert mode, critical problem. So those are the problems that are coming when we start versioning individually. And I much rather the separate code bases. I think it gives more flexibility. And also I think that you can't get away from versioning and version conflict stuff, because even if you have monorepo locally in your organization, you're going to be consuming stuff from the outside world. And this is not monorepo, right? This is you're going to have to face the versioning issues. However, many companies are very successful with monorepo. They built tons of great tools around that to make it useful and successful and productive. And it's also possible, right? LinkedIn chose a different path. We wanted to separate code bases, individual versioning. Some other companies like Google, Facebook succeed with monorepo. Good for them. How does Gradle fit into that picture of the world of dependencies? We have excellent APIs in Gradle to manage the dependency resolution, and more APIs will be coming, I hope. So let's look at some of them. The way we do dependency versioning at LinkedIn is all the software components that are developed, tested, and published from a single code base, single multi-product, they have the same version. They also share the same group ID coordinate. This makes it easy for us to identify that these software components come from this larger component, and we can make certain decisions about the version conflict resolution. And let me show you an example. So this is some dependency graph that we see here. And so far, so good. It's pretty interesting. What happens if component C brings B library, which is different than bimpl and different than BAPI, totally different jars, but version 2.0 of B library. And in this situation, in like, for Gradle, Maven, or Ivy dependency management, it's not a problem. It's not considered a conflict. And potentially it isn't a conflict. Potentially things work. But you can see something tricky going on here. Like B library, bimpl, and BAPI, they all come from the same code base, from this multi-product B. And they are only guaranteed to work correctly together if they are on the single version, because they were developed, tested, and published together within the single version. However, in this case, on the class path, we might have different versions of subcomponents of this larger component B on the same class path. So it's kind of tricky. And maybe in that case it's OK, but what if B library actually depends on BAPI 2.0? And now this is flagged as a version conflict for Gradle and Maven, and it will be resolved to one of the versions. But we have this issue that if we resolve to 2.0, so BAPI as a single component 2.0 at the class path, maybe bimpl no longer works because it's not compatible with 2.0. If we resolve to 1.5, B library probably does not work because he starts to consume BAPI at 1.5. So it's getting tricky now. At LinkedIn, we actually solve that use case because we have the concept of multi-product and because we have Gradle that has nice dependency resolution APIs. So at LinkedIn, what we do is every code base, every multi-product has this JSON file that contains your dependencies, your first level dependencies. It's sort of platform agnostic, which means that we have product spec for all technology stacks. Like, it's a Java project or, iOS or C++, whatever, JavaScript. We have a consistent and standard way of declaring dependencies. And what we can do here, and we use Gradle for that, is we can enable consistent versioning. So in this particular case, I'm declaring dependency on like 4 libraries from the Pegasus multi-product or codebase, and at version 8.1.7. This means that during dependency resolution for my codebase, whichever subcomponent I'm building within that codebase, like all the components of Pegasus multi-product will always have that version. If I'm picking up some other libraries from Pegasus transitively, Gradle will guarantee us version 8.1.7. Actually, it's not Gradle. It's LinkedIn Gradle plugins. Using Gradle APIs will guarantee this version consistency for us. We also have single source of truth for dependencies. So we look at product spec, and this is the version that is used. And we also need to take care for downgrade violation. And I want to tell you what that downgrade violation is. Because at LinkedIn, in the product spec, the version that is declared there is a source of truth. What's happening is that this multi-product A declared the version 1.5 of B component, which means that during the conflict resolution, we will actually resolve that version to 1.5, not to 2.0. By default, Gradle will just pick the latest, right? At LinkedIn, we will be picking up the version that is declared in the product spec. And this is problematic for this case, right? Because what's happening is that B library would be at version 1.5, and we don't know if component C actually works correctly when B library is downgraded to version 1.5. So this downgrade is a problem in the way how we do dependencies at LinkedIn. So what we do, we fail the build early saying, hey, you're downgrading effectively one of your transitive dependencies, fix it. So what's the fix for that? What's the proper fix for that? We can, what we do is basically the product owners of A have to bump the version of B to 2.0, or maybe higher, and they resolve that conflict this way. So that was the dependency validation rules and certain things we do with conflict resolution. We also leverage dependency rules from Gradle to tweak the dependency resolution. And what it means is that there are some known versions of various libraries that are not working correctly for us, and we can basically automatically, during dependency resolution, replace them with the correct versions. I want to show you some examples from our code, how we've done that. And this is not showing the API of Gradle at all. It's just showing you the sort of a data structure that we use to declare some of those rules. So you can see that for all the native versions starting with 3.10, we're actually replacing with 3.9.6 final. And it's a nice, convenient way for us to like roll out certain tweaks and improvements to dependency resolution to all the teams at LinkedIn, because all the teams at LinkedIn are using the Gradle plugins, so we can kind of influence the dependency resolution like across the board. It's kind of nice. Another interesting aspect of working with separate code bases and in the world of dependencies is that it's kind of hard to make changes and code changes that span multiple code bases, right? With the big single code base, it's easier. It's nice because you can, like, you have some method that is used in 1 million places. You just rename it, and it's going to be renamed. You can commit that atomically. It's kind of nice. Provided that your project loads to IDE correctly, then that could work for you. However, and then you go to separate code bases now, and you want to rename a method. Now, like, that's problematic because as soon as you rename, you publish a new version of your library with rename method, and like your consumers cannot really easily consume that version because they will have to update their code, or you have some runtime incompatibilities. So it's getting problematic. So how we have addressed that at LinkedIn, we actually sponsored the development of a Gradle composite feature in Gradle late last year, and we have rolled it out at LinkedIn in the form of like Gradle plus some feature that we added to our LinkedIn IntelliJ plugin. So for example, at LinkedIn, what you can do is when you are checking out multi-product from source control, we have actually like a separate checkout window in our plugin. We can specify which code bases you want to work with. You can actually select multiple code bases, multiple multi-products, and it's going to check it out into a single IntelliJ window, so you can do like cross code base refactorings and stuff. So that's pretty nice. That's one of the things that we are trying to do to make it easy to work with those separate code bases. In 2017, like, we observed that majority of the projects and technology stacks at LinkedIn are built with Gradle, which is kind of nice. This is not something we've been observing like at the early days in 2011. It was like experimenting and prototyping. And then it gives us very interesting, like it helps engineering to scale if we have consistent layer of tools that are built on top of like similar technology. Gradle is responsible for various things. For typical JVM stacks, it's doing all the work, all the heavy lifting. For some of the technology stacks like JavaScript or Python, we actually delegate from Gradle to some native tools. So Gradle is like a Uber build tool or an orchestrator. Play on Gradle is coming. I was just talking with Will Surgeon from Lightband like just before this presentation. So it's coming. So Play framework is a web framework that is used at LinkedIn. And right now, Play framework needs SBT to perform builds. And SBT is a fantastic tool. I don't know if you have pleasure of working with SBT. And we are trying to make our Play applications be developed and tested and built with Gradle. And it's a new thing for the Play community, essentially, because Play community for years was built with SBT. But now, as Play framework is transitioning from, like, usually it was a tool associated with Scala community, but now it's transitioning to be open for everybody, for Java developers, and you can write Java with Play frameworks easily. We want also use a Gradle tool for that. This gives us a consistent tooling for everything. Now, what's happening is that we have to maintain some of our infrastructure and dependency resolution in the form of SBT plugins. If we converge on Gradle, that helps. It's like a common build platform. We can reuse how we do dependency resolution across all the technology stacks. It's nice. It helps at least scale my team for sure. Hopefully scaling engineering and LinkedIn as well at scale. Oh, this is one interesting thing. So we don't like monorepos and monoliths. Yeah, we don't like it. About in 2015, like all the LinkedIn Gradle plugins were in their own little monorepo. So when a team had some niche requirements or use case for doing anything with project automation, they would create a Gradle plugin in that big giant collection of all the plugins. And that was very problematic for us because, like, if some engineer wanted to change his little plugin that is used by a handful of teams. He had to really, make that change in our entire code base. We have to publish a new version, so like roll it, like all our Gradle plugins to like everybody. Like we didn't want to do that. So basically we busted that monolith into separate code bases, separate Gradle plugins. And we created Gradle Platform API at LinkedIn. What it means is that if you have a need to do something custom with your automation or bring in a new technology stack and you leverage Gradle tooling and LinkedIn tooling, what's happening is that you can use that API. We have documentation for it. We have strategies for distributing your plugins at LinkedIn as well. So it's kind of nice. It really allows to scale. It offers that flexibility, right? We don't have to maintain those plugins. People can just create them and maintain them themselves. It's kind of nice. It was a key feature, key aspect of of my happiness in 2015. Like, we don't have to maintain all that stuff. And I want to talk also about some other dependency engineering tools, and I want to see how am I doing with the time. Oh, nice. Dependency engineering tools, those are not really connected to Gradle that much. Some of them are loosely connected to Gradle, but they are very relevant to the world of dependencies at LinkedIn, kind of how we manage like versioning and separate code bases. So I want to kind of go one by one and talk about them. So at LinkedIn, we have a concept of downstream dependency testing. So if you are making a change in your multi-product, your code base, and you're committing that change, we automatically trigger builds of all the code bases that depend on your code base, all the multi-products that depend on your multi-product. And you're going to get a signal. If you broke compatibility and one of your clients fails, you're going to get a signal from our continuous integration infrastructure. It's also super easy to trigger that kind of validation from your local. You just issue one command line operation, and what we're doing is like we look at what you have changed in your workspace. We send that diff to our like CI cloud. Then we build your code with that change, and then we build like other code at LinkedIn that depends on your code, and will tell you if you're broken some one of your clients. This is nice. We have rich metadata that is attached to versions. So when you're publishing a new version of your component, you can at some point in the future like deprecate that version or even like end of life it. And like if you know that some version of your code has bug, we can actually like annotate that and kind of make that information persistent in the organization. And like what's happening is like all the other code that depends on that version will stop building and tell you, hey, you're depending on the bad version, you gotta like update to a newer one. Or it'll get warnings like, that you're depending on the version that will be deprecated in 2 months from now, can you upgrade? And this is the migration guide, this is what you need to do. We also support wildcard versions, like dynamic versions. And you probably know dynamic versions, dynamic dependency resolution from like, in Gradle you have this plus sign to get the latest, and in other build systems you have something similar. At LinkedIn we have a concept of a wildcard version. So in the product spec file that I showed you earlier, you could declare versions with the wildcard, and that wildcard actually understands the version metadata. So if like a version is end of life or deprecated, it's not going to be picking it up. So it's kind of like one layer, like it's smarter than like standard dynamic versions that you have, let's say, with Gradle. We also have a system called Push My Upgrade. This system is useful when you need to roll out your version to your customer. So there is an automated service that will basically check out each of your clients, change the version, run the build, and if the build is successful, automatically push that change, and you can like easily roll out your versions. And like this is one of the things like we needed to implement in order to like make this work in separate code bases with separate versioning kind of useful. Like before, when we had everything in like a single code base, like you don't have to push your upgrade at all, because you make the change and you have to change all that code that is using that code, so you get it for free. If you have separate code bases, multi-repo or not, you gotta have tools or like processes around like consuming new versions, pushing your upgrades and stuff like that. We also have various continuous delivery services and tools. if you create a new multi-product at LinkedIn, it'll get automatically like all the CI builds and deployment and everything. What is interesting about how we do continuous delivery is that basically every change you make in your software results in a new version. And that's not the typical way things are done in the software industry, I would say. Typically, let's say a team uses Git, and they basically stack one change on another. You know, one developer does this, some other developer introduces another feature, and at some point, they decide to release. You know, some maybe once a month, maybe once a week, maybe there's some automation that releases every day, I don't know. But generally, every day, you create a new version of your software or library or something after a couple of changes were added to your branch. This is not how we do it at LinkedIn. At LinkedIn, if there is any change to your code and that change passes the build, you're going to get a new version that you know, people can consume. And this is also how we do it in Mockito. And I don't know if you are because there's a community is divided whether it's a good idea or bad idea at Mockito. Too many versions, like don't do it. You know, release once a year, nicely polished version with like beautiful things. And but this allows us to scale Mockito open source project because we have sophisticated automation around like, you know, validation that, you know, we didn't break things. And when the build passes, we merge a pull request in Mockito and the build passes, a new version gets released. We get automated release notes, documentation, and everything, and new version lands in Maven Central. And people are scared. Oh, I updated Mockito just yesterday, and now there's a new version now. What's going on? So I want to nudge community, and at LinkedIn we do that, to more like continuous delivery mode. Like, you should not have unreleased changes on your master. This is like liability, and this is waste. Stuff should get out. Stuff should be high quality and reviewed, and you know, once it lands on your development branch, it should get released and pushed. And we at LinkedIn have tools for that. One of the last things I want to mention that since we started working with Gradle, we partnered with Gradle Incorporated, sponsoring certain features in open source. And it's kind of nice because LinkedIn sponsors features that then you can use if you use Gradle. And like other companies do that too. And partnering with Gradle Inc. was successful for us. The last feature that we did last year was composite builds. The previous feature that we worked with Gradle Inc. was Play on Gradle, so being able to build Play applications with Gradle. And Play on Gradle project is still going on. My team is like full speed on this project, and we should have production use of Play on Gradle within like few weeks. We shoot for Q1. That should be good. And that's it, guys. I think I have nice time to take any questions you might have. No questions? All right. It's a great question. The question was whether every change goes to production. I should have told that. Thank you. No, not every change goes to production, but every change publishes new version. And now it sort of depends on the kind of your application. Let's say you work on the Java library. So when you are in production, when you are a Java library, you're in production if you have any client that builds his code with your new version of your thing, right? So you make your change to your Java library, the build passes, like this code review. There are other parts of the workflow that I don't mention. But the build passes and the new version is available for everybody. As soon as somebody picks up that new version, you have that production use. And it kind of depends because you might have clients that are on the wildcard version, which means that as soon as you publish, and there are like some other builds cranking, and at LinkedIn we have tens of thousands builds every day. Like it's like we have 5,000 of those code bases multi-products, so it's like pretty large scale. When it comes to applications, then you have some, you don't want to like publish new version like every second, right? So for example, for LinkedIn site, we publish every 3 times a day. But of course, there are like many changes during the day because many engineers are working on it. And also there are changes in many layers, right? In front end, in the mid-tier and stuff. So really, so the short answer is not every version immediately is on production, but is available for production. And it really depends on the context and what kind of multi-product it is. when it's really in production. Hope this answers your question. Yeah, you gotta have automated tests that will tell you with guarantee that your stuff works. Like we don't do like manual testing at all at LinkedIn, not like zero, ever. And we used to like many, many years ago, but not now. Like we have some like exploratory testing. You have canary releases. You have like beta version of the app that goes out to LinkedIn employees. So we have ways of like mitigating risk and kind of figuring things out, but we don't have manual testing process that is like a part of the release workflow, or at least, okay, there are like many, many applications out there at LinkedIn, and I'm not an expert on like entire portfolio of like tools that the applications that LinkedIn provides, but like the main ones that I was connected with, let's say the LinkedIn site, there's no like a manual process where someone actually validates and say, yeah, let's ship it. Any other questions? We use Gradle, and we are very happy with Gradle, but like, there is a steep learning curve, and especially when you want to extend Gradle and do like really sophisticated stuff, you suddenly find yourself that you need to browse Gradle codebase internally to figure out how things work. So I guess it depends on like, not really, like you have the documentation on Gradle, yeah, that everybody knows, like DSL API and this and that. In general, the documentation on Gradle is very decent. But because that tool is pretty complicated and it's very ambitious in what it wants to do, like there are so many APIs there, so many like incubating APIs that are not yet that well documented that, if you are like also ambitious user and you want to do really cool stuff with Gradle, you're going to end up going deeper than the Java docs, right? Even to the code and stuff. Yeah, I mean, it's going to get better, especially as Gradle is opening to Kotlin. It's now already possible to create your build.gradle file scripts in Kotlin, which automatically gives you much better like syntax highlighting and IntelliSense and like support in IDE when you're like working on your scripts. But yeah, but it's coming. It's slowly getting there. If you're interested in joining some of the efforts that I briefly talked about, like the Mockito release tools, where we want to like nudge the community to be more continuous delivery, to push the Java libraries in the world to like release more frequently rather than just stacking changes and then, I don't want to release. It's just too many changes. It's going to hurt us, and I don't want to create release notes because it's just too much work, right? So like, hit me out on Twitter or something. Like we can chat. Any other questions? Yeah? It's a great question. What about like service dependencies and like the various things I mentioned about like dependencies? I would say that service dependencies have, to some degree, yes, but services have their own ways of like, let's say, validating the APIs and stuff like that. So there's I'm trying to find like what's the good answer here. I would say that if you have a multi-product at LinkedIn that is an application that depends on some service, right? You are going to declare a dependency to the API of this service. And now it kind of depends what kind of technology stack we're talking here. We have some like official ways of like, or like building dependencies between services and kind of depending on the middleware and stuff like that. The technology there is RESTly, it's also open source, where you have some ways of validating that you are like compatible with the API that you're consuming, and you have ways of generating the client code that talks to that API. But generally, you would have the dependency. You would have those explicit dependencies to the services layer, and that dependency will enable some of the features that we have at LinkedIn, like the dependency testing mechanism, and certain other things. Yes, that's exactly how it works. Yeah. Yes, it is supported. With services, you have even more features, because what we have with RESTly is that when you are producing a service and an API, you can validate your compatibility without actually, like, in your code, because you have ways of like detecting that you made the change that is compatible or not compatible. So you have even better ways. With Java, we don't have those tools, right? With Java, it's kind of, you got to know when you're making breaking change or not. Although there are open source tools in Java that offer that insight. It will tell you, hey, you're making incompatible change, or you're making good change. But we don't have that yet. I would love to implement that. But like in general, yes. Like if you have service-to-service dependency and that kind of stuff, it also participates in that machinery. Any other questions? Okay. Thank you very much then.